In this tutorial, we are going to discuss about the chain rule for derivatives, and for applying the chain rule, we need to know about the composite function. Y is equal f of t and t is equal g of x. So we have here the variable y, then t, then x. So this derivative is dy dt, and this derivative is dt dx. But if we need a derivative is dy dx, then this can be given as dy dt multiply dt dx. So this idea, this concept is known as the chain rule. Say how the composite function is expressed here. Y is equal f of t and t is equal g of x. Then we can write that y is equal f composition g x. So this is f of g x. So in this case, if you have the derivative y dash is equal f composition g dash x, this is equal f dash gx multiply derivative of g dash x. So this is two form of the chain rule. Now we'll see the examples of the composite function and we'll try to find the derivative using these functions. So it's given that y is equal sin t and t is equal to x. Then the question is find dy dx. The solution here, so we have to find dy dx, which is dy dt multiply dt dx. So now calculate dy dt and dt dx. So dy dt, which is d dt of sin t, is equal cosine t, and dt dx is equal d dx of 2x, which is equal to 2. So we got here dy dt is cosine t and dt dx is 2. So this is equal to cosine, and one of the things here we need to know that the final answer should be with respect to the final variable, independent variable, so which is x here. So it is known as 2 cosine 2x. So the y can be think as a composition of two functions. Let f(x) is equal sin x and g of x is equal to x. Then y can be written as f composition g x is equal f of gx, which is equal sine of gx is equal sine 2x. So therefore, this way we can see that how the composition function is there. So now in this case, the derivative, so y dash is equal f composition g dash x, which we already discussed it before, that is f dash g x derivative of g dash x. What does it means here? That f dash, so we need to know the f dash means the outer function. What is the derivative of the outer function? And here derivative of the inside function. So in this case we have here, for this problem we got y dash is equal d dx of sine 2x. So outside function, derivative of the outside function, so derivative of sine is cosine, inside whatever it is, and derivative of 2x, so which is 2. So we have here 2 cosine 2x. This is the final answer. We solved this problem in some other video, but there we use the product rule. Here we will solve it by the chain rule. So dy dx is equal to d dx tan x whole square minus d dx of secant x whole square. Now here we have the power rule, and then inside there is a tan, so derivative of tan rule. So outside function is the power 2 and inside function is 10x. So therefore by chain rule we will have here 2, then 2 tan x, derivative of the inside function which is tan x minus 2 secant x and derivative of secant x. So simplify this one, we will get it here 4 tan x, and derivative of tan x is secant square tan x, and derivative of tan x is secant square x minus 2 secant x, and derivative of secant x is secant x tan x. So simplify this, 4 tan x secant square x minus 2 tan x secant square x. This is equal to tan x secant square x. dy dx is equal d dx of cosine e to the power x plus d dx of e to the power 5x. So this is by the chain rule, derivative of cosine will be sine inside function as it is, and then derivative of e to the power x plus here e to the power x, e to the power 5x, derivative of e to the power 5x. So derivative of e to the power is e to the power 5x, and then derivative of the inside function is 5x. So sine e to the power x multiply e to the power x plus 5 e to the power 5x. Solution. dy dx is equal, first we'll solve by the quotient rule. So this is 2x plus 5 to the power 6, and then 2x plus 5 to the power 3, derivative of 3x minus 3x, derivative of 2x plus 5 to the power 3. So this is equal 3, 2x plus 5 to the power 3 minus 3x. So here we will apply power rule and the chain rule. So 3, 2x plus 5 to the power 2, derivative of inside function is 2x plus 5. So if we simplify that, we'll get it here 3, 2x plus 5 to the power 3 minus, this is 3x, 3 9x, and this derivative will be 2. So we'll have 18x and 2x plus 5 all square and 2x plus 5 to the power 6. Now this 2x 5 we can take common, 2x plus 5 to the power 6, then we'll have 2x plus 5 all square, 3 into 2x plus 5 minus 18. So this is for the simplifications, the power will cancel out. So we'll get it in the numerator is 6x plus 15 minus 18x, and it is 2x plus 5 to the power 4. So this is equal minus 12x plus 15 over 2x plus 5 to the power 4. Method we are going to solve it rewriting. So y can be written as 3x and 2x plus 5 to the power minus 3. Then using the product rule we have y dash is equal 3 can be taken out, d dx of x, 2x plus 5 to the power minus 3. So we'll use the product rule here. So this is 3 and then x, derivative of 2x plus 5 to the power minus 3 plus 2x plus 5 to the power minus 3, derivative of x. This is equal 3. So derivative of this one is x minus 3, 2x plus 5 to the power minus 4, and then derivative of 2x plus 5 plus 2x plus 5 to the power minus 3, derivative is 1. This is equal 3, and then we are going to simplify it, minus 3x over 2x plus 5 to the power 4, and this derivative is 2 plus 1 over 2x plus 5 to the power 3. 3. Then if we take this common, 2x plus 5 to the power 4 minus 6x plus 2x plus 5. 3 minus 4x plus 5 over 2x plus 5 to the power